Okay, section 8.2 is talking about points, lines, and their graphs. And so all of you have a little coordinate grid for you guys. Yes? Okay, so all of you guys have a coordinate grid. Okay, the first thing that we're going to talk about is the different parts of this coordinate grid, the things that make up this coordinate grid, different properties of this coordinate grid, and a lot of this stuff isn't going to be new. Big part of your homework assignment tonight is giving the coordinates of a point. Or, if I give you a coordinate, telling me what point goes with that coordinate. Stuff that you guys probably started back in like 4th grade, but it's also probably been a while since you guys have done stuff like this, so we're going to start from the very beginning. We're going to kind of go over everything like you've never learned about it before, so it's going to be super easy, and then we're going to actually start graphing today. Not graphing on graph paper, they're going to be very kind of vague graphs, but we'll start graphing today, okay? So the first thing, we're going to look at this coordinate grid. We're going to label some things on this coordinate grid, things that are kind of interesting, things that maybe you not necessarily didn't know, but just didn't notice. So first thing, the two major big parts that make up this coordinate grid are the two lines that make this coordinate grid a coordinate grid, right? The first one is that horizontal line. It's kind of like the starting place, right? And it's kind of like just a number line, isn't it? Right, isn't this just a number line? I have 1, 2, 3, or I have -1, -2, -3. What is this horizontal line called?
X-axis.
The x-axis. Okay, so we're going to label that first. Okay, so the x-axis, it's just a number line. If I start here and I go to the right, these are my positive x coordinates. Okay, if I go to the left, those are my negative x coordinates. So yesterday, whenever you guys were finding answers 1, 2, that 1 is a positive 1 on your x-axis. Okay, probably not news to you guys, but just kind of going back over this. Okay, well, let's talk about the other really important line on here, and it's the one that goes up and down. That vertical line is called what?
The y-axis.
The y-axis. Okay, and then this is actually just a vertical number line. A horizontal number line, like we talked about back in chapter 10 when we were graphing inequalities. But this is just a horizontal number line. If I start here and I go up, that would be +1, +2, +3. If I start in the middle and I go down, those are my negative numbers. So if you had 1, 2, the 1 is your x coordinate. The 2 is a +2 for your y coordinate. Okay, we will go back. We're going to graph some coordinates, but not just yet, because there's one other super important thing on your coordinate grid that gets overlooked all too often, and it's that center point there. The point at where the x and the y-axis cross, where it all begins. What is that called?
Origin.
The origin. Very good. So we do want to label that because it's very important. I have my origin. Okay, big thing today is going to be talking about coordinates in x, comma, y. What is the x, comma, y? What are the coordinates of my origin? 0, 0. It's where it all begins. 0, 0. Right? Because 0 is my x coordinate. Well, I'm not going anywhere on my x-axis, right? I'm staying at 0. Same thing with y. We're not going up. We're not going down. We're staying at 0. Okay? Questions about x-axis, y-axis, origin? Pretty easy stuff? Yes? Okay, let's talk about some points. What we're going to do is we're going to go through and we're going to plot a point in each one of these sections. Because if you kind of notice, my x and my y-axis create 4 different sections. These 4 different sections are called quadrants. Okay, and we'll come back to the name of these quadrants. But they create quadrants. And in each one of these quadrants, the coordinates have certain similar features. Okay, so we're going to go through. We're going to plot a point in each quadrant and kind of talk about each quadrant separately. So first, I want to plot the point 2, 2. I want to plot the point 2, 2. So that first number, that's my x coordinate. That tells me if I'm starting at 0, I need to go 2, right? 2 places to the right. And then that second number is my y coordinate. It tells me whether I'm going to go up or down and how many places up or down. And since it's a +2, I'm going to go up 2 spaces. So 2, 2 would be about right there. Okay, before I move on to my next coordinate, I want to look at some things. If I'm talking about all of the coordinates here, wherever I plot a coordinate, if it's in this section here, what are some things that all of those points have in common?
Both are positive.
Right. My x coordinate is always going to be positive, and my y coordinate is always going to be positive, right? Because you're always going to go to the right on your x-axis, and you're always going to go up on your y-axis. Your x coordinate is always going to be positive, and your y coordinate is always going to be positive. It's always going to be a positive number, comma, another positive number. Okay, so if you're given a coordinate, and it's a positive, comma, positive, you know it's going to be somewhere in this area. Okay? All right, next one. Let's plot -3, 1. This time, that first number is negative, so that tells me starting at 0, I need to move to the left this time, and I'm going to go left 3, but I'm still going to go up because it's a positive 1. So -3, 1 would be about right there. And we're going to kind of do the same thing. So we said in this first area right here, I'm going to have a positive x and a positive y. Do you think there's a similar way I can classify all of the points in this area? Yes? Right. My x coordinate's always going to be negative. My y coordinate's always going to be positive. Okay? Making sense so far? Yeah, nothing new, hopefully. Okay. Next one. Let's try -2, -3. Okay, my x is negative, so I'm going to move to the left 2. And now my y is negative. So instead of going up, I'm going to go down 3 units. So -2, -3 is going to be in this area right here. Okay, and how do you think I can classify any of these points? Very good. My x value is going to be negative, and my y value is going to be negative. Negative, comma, negative. So if you're given a point and they're both negative, it's going to be somewhere over here. Okay? And last one, let's try 4, comma, -1. My x value is positive, so I'm going to move to the right, but my y value is negative, so I'm going to go down. So I'm going to go 4 to the right and 1 down to plot 4, comma, -1. And how could you classify all of these points, Lydia?
Positive.
Right, my x value is positive, but my y value is negative. Okay, makes sense? Okay, next thing I want you guys to do. These coordinates are kind of super important, and in your homework tonight, you're going to be asked to give a point and tell which quadrant it's in. Okay, so we kind of need to have a name for these quadrants, and they came up with names for these quadrants. But they're not super descriptive names, not super creative names. Anybody know what the name of these quadrants are? Abby?
1, 2, 3.
Right, how fun. I would have named it something so much more exciting than that, but they didn't. They named it quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the next thing we're going to do on your graph, we're going to label these quadrants. But we're going to do this in a way that it'd be kind of helpful. So you're going to take your graph and you're going to take one corner of your coordinate grid and fold it to the origin. Okay? And you're going to do that with all 4 corners. Okay? So go ahead and whenever you're finished, it should look kind of like a diamond, okay? And then I want you to glue that into your notebook, okay? So when you're finished, whenever we're done labeling the quadrants, your notebook's going to look like this. You're going to have your graphic organizer glued into your notebook, okay? So take a second to do that. Okay, so the next thing we're going to do is we're going to label these quadrants. So, quadrant 1, and you can't just put them anywhere. They have specific names. They go in a certain spot. Anybody know where quadrant 1 is? Where's quadrant 1? The top right hand, where everything's positive. Everything starts where everything's positive. So that top right hand corner, that is my quadrant 1. And how they label these is a capital Q and a Roman numeral 1. So they talk about the quadrants in Roman numerals. Okay, you don't necessarily have to do that. If you really like just regular numbers, you can do that, but you just need to be familiar, okay? Now, after this, you don't get to just choose where quadrant 2 goes. They have this all planned out, okay? So, quadrant 1 is where everything's positive. And after that, to fill in the rest of them, you work counterclockwise. So that means to the left of quadrant 1 is quadrant 2. And then if I go down 1, that would be quadrant 3. And then the last one would be quadrant 4. Once again, all Roman numerals. Okay, so some of your homework tonight, it's going to give you a point, and it's going to be right here, and you're going to have to give the coordinates, and then you're going to have to say what quadrant it's in. So this could be really handy tonight working on your homework, okay? Okay, so far we've kind of reviewed how to plot points. We've talked about the 4 different quadrants and the different characteristics in each quadrant. Any questions so far? Okay, so a lot of that stuff's not new, hopefully. Done it before, may have been a while, but we've all done that before. Probably going to be new, okay? Next part, we're going to start graphing a line, okay? So, throughout this chapter, we're going to learn several different ways to graph lines. This is going to be the first way to graph a line, and in certain situations, it might be the easiest way to graph a line. We're going to learn a more convenient way to graph lines later on, probably next week. But if we're talking about graphing a line, regardless what method you use, you have to have 2 points, right? Because if I have 1 point, how many lines could you draw through just 1 point? An infinite amount, right? You could draw that. You could just keep drawing points to that line. But if I have 2 points, how many different lines can you draw through 2 points? Just 1, okay? So if I give you an equation and I want to graph it, all I really have to do is find 2 points. And you guys kind of did that yesterday. If I gave you an equation, you found a bunch of different points on that line, right? Some of them you found 6 points. You found a 1, 6 and a 2, 3. You found a bunch of them, okay? So that part's not new today, okay? Finding points on a line. But there's 2 points that are really, really easy to find. And they're the 2 points that you see in blue on the board. So let's say I have this line here, and I want to find these 2 blue points. Okay, so I want to find any 2 points on this line. Now, any line, almost any line in the entire world is going to cross the x and the y-axis at some point in time in its life. Okay? Now, not every single line. There are some certain specific lines that won't cross the x-axis or they won't cross the y-axis. But most lines, because they keep going and going and going and going, are going to cross the x-axis sometime, and they're going to cross the y-axis sometime. Those are the 2 points we're going to find, okay? We're going to find these 2 points. So let's start with where this line crosses the x-axis. This is called the x-intercept. Where my line crosses the x-axis, this is called my x-intercept. Okay, now this certain line crosses the x-axis right here. We can see that, okay? But if we talk about any line in general, let's think about what all of these lines would have in common. This line crosses the x-axis here. Maybe another line crosses the x-axis here. And another one maybe crosses it here. And the other one crosses it here. Maybe another one crosses it here. What would all of those lines, what do they have in common when they cross the x-axis?
Their y is 0.
Isn't the value of y 0? Any point that lies on the x-axis is going to be something comma 0. Right? You guys agree with that? If my line crosses right here, I don't maybe necessarily know what x is, but I know my value for y is 0. If it crosses here, maybe it crosses at -1, but my y is 0. If it crosses somewhere clear over here, it's negative something, but my y value is 0. Okay? So your x-intercept is really important and really useful because your y value is always 0. Y equals 0 at your x-intercept. Okay? Well, kind of thinking about that, let's look at the other point. Let's look at my y-intercept. Okay, so regardless whether this line crosses here, like mine does here, or if it crosses somewhere down here, or even if it crosses here, or way up top there, what do all those points have in common? X equals 0, right? So for your y-intercept, no matter where it is, your value for x is always going to be 0. Now this is important because it turns out that the x-intercept and y-intercept are pretty easy to find. Okay, well, that's how we're going to graph the lines today. Okay? So these lines today aren't going to be super impressive. They're not going to be super sophisticated. We're just going to kind of get the general idea of graphing lines. So directions will say graph And the first line, don't let me down now. The first line that we want to try to graph is 2x plus y equals 10. 2x plus y equals 10. Okay, so how many points do I need to graph this line? 2. Got to have 2. Okay? And it turns out that the 2 points that are really easy to find, pretty easy to find, are the x-intercept and the y-intercept. So let's start with the x-intercept. What do we know about the x-intercept for any line? That y equals 0. No matter what this line looks like, but when it crosses that x-axis, my value for y is 0. Okay? So if I want to find my x-intercept, I'm going to plug 0 in for y. So we're going to take 2x plus, but instead of y, we're going to plug in 0. And notice now that I only have one variable, and I could solve. 2x plus 0 just gives me 2x. So 2x equals 10, divide both sides by 2, and I get x equals 5. This means that my graph crosses my x-axis at 5. At x equals 5, I have a point, okay? Now, I don't necessarily have to do this on your homework, but kind of good to know, what is my x-intercept as a point, as an x comma y? Very good, 5, 0. Don't necessarily have to say that, but kind of good to just remind yourself, 5, 0. Okay, well, I found 1 point, and that really wasn't too bad. So let's find the other one. Let's find the y-intercept. How would you find the y-intercept? X equals 0. Whatever my line looks like, I know that when it crosses my y-axis, my value for x is 0. So I have 2 times 0 plus y equals 10. Okay, well, this is kind of nice because 2 times 0, that just kind of cancels out, and it's just 0. And 0 plus y is just y. So I find out that y equals 10. And what this means, when my line crosses my y-axis, it does this at y equals 10. So it's going to be way up there. It's going to cross my y-axis at 10. If I wanted to write my y-intercept as a point, what would it be? 0, 10, right? Because we plugged 0 in for x, and we got 10 out for y. Okay, I have my 2 points, and I could make my line. Okay, you guys notice how I put those arrows there? Why do you have to have the arrows? Because it goes on and on and on and on, just like my sister. You get her rambling, she just goes on and on and on. No matter what you say, it just keeps going on and on. Okay, so this line goes on and on and on and on. Okay? Make sense? Not too bad today. Just kind of takes a little bit of time. Okay, but the more you do these ones, the more they make sense. Okay, ready to move on to number 2? All right, number 2. Number 2 says x plus y equals 0. Okay, I need to find 2 points. The 2 points we're going to find are my x-intercept and my y-intercept. How do you find your x-intercept? Set y equal to 0, so x plus, instead of y, we're going to plug in 0. So what do I get for x? 0. As a point, what would this be? 0, 0, kind of boring, but that's okay. We'll let it slide this time. Okay, and then we want to do the same thing, but I want to find my y-intercept. How do you find your y-intercept? Okay, set x equal to 0, so 0 plus y equals 0, so I get y equals 0 too. What's this as a point? 0, 0. How many points do I need to make a line? How many points did I find? 1. Does that mean this isn't a line? Doesn't necessarily mean it's not a line. It just means it actually crosses through my origin. So I just have to find a different point. Okay? How am I going to find a different point? Any ideas? What did you guys do yesterday? You just plug numbers in for x, right? That's what you're going to do. Pick any number. Doesn't even matter. What number do you want to plug in for x? 2. Let's plug in 2. We're going to plug in 2 for x. And we're going to solve for y. So if x equals 2, what would y be? negative 2. As a point, as an x comma y, what would this be? Not 0. We didn't plug 0 in for x, right? We plugged 2 in for x. So as a point, this would be 2 comma negative 2. So if I wanted to graph this line, my first point would be at 0 comma 0, which is just the origin. My second point would be at 2 negative 2. Now here's the cool thing. Let's say instead I wanted to plug in 1. I didn't want to be like the rest of you. I wanted to make my own path. I want to do my own thing. I'm going to plug in 1. Okay? If you plug in 1 for x, what would you get out for y? Negative 1. Okay, well let's see what happens if I plot this on my line. 1, negative 1. What happens? It's on the line. It doesn't matter what number you plug in. If you wanted to plug in negative 29, it would work. You just have to do a lot more work graphing, right? Okay? Make sense? Okay? We'll try one more of these and then 2 kind of special cases, and then we'll be done with notes for today. Okay, next one. Let's try 1/5 x plus 1/4 y equals 2. Okay, we'll find the x-intercept together. I'll have you guys find the y-intercept and then we'll graph it and then we will move on. So first thing, to find the x-intercept, what would you do? Make y 0. And you guys hopefully are kind of catching on that when you make y 0, what happens to this term? It cancels out. So I'm really just left with 1/5 x equals 2. How would you get rid of that 1/5? Multiply by the reciprocal, which is 5, and 5 times 2 gives me x equals 10. What would that be as a point? 10, comma 0. Okay, I want you guys to take a second, find the y-intercept. Okay, and what did you guys get for your y-intercept? 8. And as a point, what would this be? 0, comma 8. Okay? For your graph, I told you it doesn't have to be super sophisticated. If you just kind of get the general idea. You don't even have to draw it all 10 hash marks. I would like you to label 10 on your x-axis and then label 8 on your y-axis. But other than that, we just kind of want the general idea of what this graph would look like. So I'm going to have a point at 8, a point at 10. We can connect them and off we go. Okay, questions on graphing these kind of lines? Not too bad? Okay, yes?
Do you want us to draw the whole chart or can we just use...
No, this is fine. Like how I showed my work here? Is that what you're asking?
Can you just draw like quadrant 1 or do you have to draw all 4 quadrants?
I mean, this isn't that hard to do, right? Yeah, it just, because sometimes it won't just stay in quadrant 1. Sometimes it might be in quadrant 3 or quadrant 4. So just go ahead and draw all 4 quadrants and just get the general idea. Okay? Okay, so now we have 2 special cases. You guys remember how I said any line, most lines, sometime in their life are going to cross the x-axis and the y-axis. There's some lines that don't ever cross the x-axis, and there's some lines that don't ever cross the y-axis. So let's kind of look at those lines. First one, let's look at x equals 3. X equals 3. If I want to graph this line by finding my 2 points, let's start with finding the x-intercept. How do we find the x-intercept? Set y equal to 0. What's the problem here? There is no y. There is no y. What this tells me is that this line never crosses my y-axis. If there's no y, it's never going to cross that y-axis. This vertical line here, it's never going to cross that line. How is that possible? It's going to have to be parallel to it, right? The only way that I have a line that won't ever cross my y-axis is if it's parallel to my y-axis, okay? So x equals 3, it's going to be a parallel line, which is great, but can I just put it anywhere? No, there's a certain place that it's got to go. How do you know where to put it? On the 3, right? It's this number here. at a positive 3. So on your x-axis, at 3, we're going to have a vertical line. It's never going to cross my y-axis. This is going to go up and down forever and ever and ever. And another thing that you can kind of check is that anywhere on this line here, your value for x is always 3. If you go way up top there, if it's on that line, your x is 3. If you stay on the origin, x is 3. If you go way in the negatives, x is 3. Okay? Okay, well, let's look at the other special case. Let's say this time I have y equals negative 4. Okay, kind of same idea here. Let's say this time I wanted to find the y-intercept. What would be the problem here? There's no x to plug 0 in for. So kind of on the same lines, what that tells me is that this line never crosses the y-axis. If there's no x-intercept, it's never going to cross the x-axis, and what's the only way that's possible? If it's parallel to my x-axis. And once again, I can't just draw this line wherever I want. Where will I draw it? At negative 4. On my y-axis, at negative 4, I have a horizontal line. And then kind of like with the last one, if you look on this line, anywhere on this line, my value for y is always negative 4. Does that make sense? Yes.